Today we're going to talk about APIs beyond data centers, what architecture we chose, and what the best practices are that we learned along the way. Just a quick agenda. I will talk about our current situation and what we even wanted to achieve with our new API, the architecture of our API, what solutions did we consider to scale this API across data centers and make it failure-proof. And I will also show a very short demo. So yeah, our current situation. We at plusserver host our own public cloud based on OpenStack. It's called the Plus Cloud Open. And for example, we have this cloud running in 3 different regions. This could be for us like Cologne, Hamburg, and actually we have 2 data centers in Hamburg, so could be both here. And then we have our PSKE. And the PSKE needs to access all these different clouds to distribute clusters across them. And currently our user can access the one PSKE, the one management interface we have for them, and configure the clusters there, create clusters, delete clusters, all that sweet stuff. But of course, running our PSKE and only having one management interface for our PSKE or our Kubernetes engine is somewhat of a failure point, because if the one region goes down, the clusters are still running fine in the other regions, but you can't configure them, you can't scale them up, and you can't create new clusters until we resolve the issue. So we wanted to distribute the PSKE across cloud regions, so that every cloud region would have its own PSKE management interface, basically. And if we wanted to really abstract this, we could also just connect all PSKEs to all regions, but that would probably be a bit overkill. So one problem, for example, that arises from this is that our customer now has like 3 different domains or different endpoints he needs to interface with to get the status of their clusters or retrieve or create new clusters and stuff like that. And with our current implementation, it would also mean that the customer gets 3 different sets of credentials to log into PSKE, which probably just would make him really sad. And yeah, we wanted to solve that issue so that the customer can have like a simple overview of all their clusters and all their regions, and manage them all from one distributed endpoint. So a short summary of that. So we wanted a centralized and simple access to different PSKE, so Kubernetes Engine environments. We wanted the customer to have an overview of all clusters. We wanted to simplify and opinionate the API. So currently we're using SAP Gardener as a base stack for our Kubernetes engine. And sometimes customers get a bit confused when wanting to automate against the core Gardener API. And also the Gardener API lets you configure a lot of stuff and also lets customers break their clusters if they configure the wrong things. So we wanted to opinionate the API a bit, so we could like prevent the customers from breaking things or just align the core API more with the plusserver standard. We also wanted to integrate our PSKE management better into our customer panel. So we needed a simple REST API for that squad to consume. And we also wanted to add extended functionality that wouldn't really be easy to implement into a Kubernetes native API, probably. So the architecture of our API. I think we aligned the API somewhat with what a typical modern API design looks like. So we have an API server that is largely stateless and just fetches information from a database when needed. But we can scale the API server as we want. We don't need a stateful set there or some complicated state management. We implemented the upkeeper, so we have something that like keeps our database organized and can run scheduled jobs or cleanup. And then let's add the PSKE and the agents, which is the last component we are currently developing. And the agent is basically, or has the target to sync the API state, which the API server is persisting into the database with the actual PSKE. So we have our own API, our own model of how a cluster object is structured, and the agent converts this from the API, from our own API into gardener speak, so to say. So if our customer now wants to access our PSKE, he interfaces with the new API server we created. This API server now talks to the database, in our case MongoDB, persists the state within MongoDB, and now needs to inform the agent that he has to sync or create a cluster. We chose RabbitMQ for our messaging broker. So the API emits an update into one of our queues, and the RabbitMQ forwards the message to one of our agents, which then of course begins to sync the cluster and also starts to watch the cluster for events. So if the creation was successful, if it does have any problems, if Gardener detected any problems, or if something just failed or isn't valid from the Gardener side of things. And those updates get sent through the RabbitMQ again to our upkeeper, which receives these environment updates and persists them again in the MongoDB. And as I just said, also does some garbage collection and controlling stuff. And I think this design has a couple of benefits, because we now have like a really modular, or we have a couple of components that aren't too many and too hard to maintain from our side, but we still have that decoupled, that decoupled structure where our API server doesn't directly communicate with PSKE. So if there's a problem there, it doesn't like bring down the API server or something like that. And if, for example, the agents start flooding us with status updates, the API server can, for example, still function quite nicely. Of course, we needed to host this new API somewhere. So we looked at a couple of solutions for running clusters across data centers. The first one was the stretch cluster. So running one Kubernetes cluster with worker nodes and control plane nodes in different data centers. Of course, this has a couple benefits. We only need like one or a couple clusters that we maintain. Application traffic between these regions is relatively simple because we can just use Kubernetes networking to forward traffic across regions. Of course, we need to establish a connection between the regions, but that could be easily solved with a VPN or like L3 routing. And failover stateful applications is quite simple because we can use the normal Kubernetes operators or just stateful sets. But there are also a couple of drawbacks. We can't use PSKE clusters because our PSKE only supports running clusters in one region and not stretching them across a couple regions, which would make it somewhat of a unicorn in our organization because we would need to evaluate different tools for maybe bootstrapping those clusters or even write our own automation. Most tools don't support stretch clusters across regions. So out of the box. So running, for example, KOps or kubespray across different regions isn't really supported. Clusters are highly affected by latency between regions. So as we would need to run control plane nodes across all regions, latency between those could easily bring down the Kube API server or other functionality, for example, leases or stuff like that, if the latency gets too high. Moving storage is also really complicated because we don't have like an easy in-sync persistent storage that we can share across data centers. Yeah, and upgrading that cluster could also like affect all regions at once if something goes terribly wrong. And of course, if we need to write our own automation, we don't have auto-scaling out of the box. So we looked further into multi-clusters. So multi-clusters also have a couple of benefits. For example, we can use PSKE clusters now, which we could spawn in different PSKE regions or cloud regions. The regions are decoupled, so problems in one region don't affect the others. Service degradation in one region can't spread to others. So as I just said, like latency or storage latency doesn't really affect clusters running in different or in other regions. And yeah, we could also like run these clusters in different PSKE environments or stages. So for example, we could, if one PSKE update goes bad or something like that, we still would have the API on a different environment with a different patch state, for example. But there are also, of course, a couple drawbacks. More clusters means we need more to keep track of. Stretching stateful applications proved really difficult because, like, okay, I have one pod running in this cluster, one pod in the other cluster. How do I connect them? And how do I do this automatically or in a CI/CD pipeline? Yeah, it also introduces the complexity of service meshes, which are their own beast, I guess. And of course, it's a higher development effort on our side because we need to write more software that creates these clusters, maintains them, installs software into these clusters, connects them with each other, stuff like that. So, what is our current setup we are trying to run? We have 3 regions: region A, B, C, or 1, 2, 3. We have the API clusters. We chose to run the API in its own cluster, so stuff like databases or the messaging service or other stuff can't bring down the API cluster or overload it. We got our DB clusters in which the MongoDB is running, and we got our RabbitMQ clusters. As I just said, we installed our API server and the upkeeper into the API cluster and put the upkeeper on different nodes, or worker groups, as Gardner calls them. We got the MongoDB, and of course we got the RabbitMQ into the RabbitMQ cluster. In our case, we just used the MongoDB enterprise operator to stretch clusters, stretch the MongoDB across clusters. MongoDB already provides you with an operator that can orchestrate MongoDB across clusters. You just need to set up Istio first in a bit specific way to enable to communicate with each other. And then we clustered RabbitMQ across multiple Kubernetes clusters by just spawning multiple RabbitMQ instances and basically editing the config to connect them to different exposed RabbitMQ instances. Yeah. As you see, we still have bit of work to do. I grayed out the 2 upkeeper instances, for example, as we are still working on stuff like failover for this component, because it does like garbage collection and controlling. It can't easily run on multiple clusters or instances at once. But we're still working on like a sharding mechanism and like proper leasing with another tactic like the Kubernetes API. So now I can show you a short demo regarding the API. I installed I hope you can see this now. Yes, nice. So I installed the API on my local machine running in a local setup. If I now show the Docker containers running right now, we have the API server, we have the upkeeper, we have the agent. So all components running on my local machine right now. If we can even look at the logs of the different containers and see like, okay, we're doing some health checking and stuff like that. And I set up a kubeconfig to one of our Gardener setups here. So I can, for example, look at the projects Gardener currently knows about. Yeah, there are a couple. Isn't really relevant to this talk. Now we can send we can look at the API and see, okay, if you don't specify anything, it of course doesn't find a page. But if we, for example, send a post request now to, where is it? Okay. If we, for example, send a post request now to the API under the v1 project URL and specify a name like demo CDS, we get a reply back from the API telling us, okay, the operation has started. And of course, we can now also curl the API for this. Nope. For this object we just created. Yeah, and you see the agent already gave us some information back that the operation started, that the agent received the request, and that the project got provisioned. If we now look at the projects again in our Gardener setup, we see the project obviously got created. Excuse me, I got a bit of a cold getting here, so a bit broken voice right now. But yeah, and now that the project got created, we also can list the clusters within the project. Of course, currently there are none, so we just get an empty array back. And if we send another post request to the now project demo CDS clusters URL, specifying our cluster JSON, which is here. Oh, I forgot to scale that up. So now we want to tell the API, okay, create a cluster with the name test3 in our dev environment with the cloud profile plus cloud open, so on our own OpenStack implementation, with the following worker groups. So one worker group with the name test1, using the flavor and the machine image we specified. We can now send this request. We get the object back again. And if we now pipe this through a JQ, for example, we see that the agent also started to, or it received and accepted the request. We have component states here. We have our last operation, so it's currently now in the creating status. And if you want to, we can look at the namespace Gardener allocated for our project and list the shoots, which are basically the clusters within Gardener. And we see that our cluster got created. So if the cluster now would finish creating, which we won't wait here for, we could also like retrieve the kube config for the cluster we just created. Yeah, but cluster creation takes a couple minutes, so I won't bore you here. And now we can also look like at the logs from the agent, and we see like, okay, the agent recognized the cluster doesn't exist, so it creates it. Yeah, and sends back feedback information. So you don't need to understand everything that is in this log right now, but yeah, the decoupled structure basically worked. And now we can also like wait for the cluster to finish creating. And that's basically what I have for today. Bit kind of rushed through this, I think. But yeah, you can try our PSKE in its current state without the API. 30 days for free. It will get deleted after the 30 days automatically. And of course, you don't have any costs. And also, if you are interested in trying everything PSKE has to offer, we currently have like a special offer where you can get PSKE 2 months for free. So just come by and check out our booth here. And yeah, if you have any questions after this talk or just want to stay in contact, yeah, there's my LinkedIn profile and stuff like that. So yeah.
Have a round of applause. I really enjoyed how you started your presentation by thinking of the customer. Yeah. And it also made me feel like, you were really sharing something you were actively working on. So did you manage to catch the fireside chat with Kelsey?
No, unfortunately.
No. So in that talk, he cautioned against running databases in Kubernetes. So one of the questions relates to that, and it says, why did you choose to run MongoDB in a Kubernetes cluster?
In our current stage was basically just ease of use, and we wanted to basically try if we can get it running at all. So if we're still looking at the possibility if we need like more performance because we have other storage solutions that don't work in Kubernetes, in our Kubernetes solution right now. We will maybe switch to other solutions, but it's just like for a quick developer experience right now.
I understand. The next question is, how do you load balance / failover across regions?
Yeah, currently we're using an external content delivery network to fail over between the 3 different API endpoints. But we're also looking at like failovering the actual IP between, so the public accessible endpoint between data centers.
The next question is, how big is the overhead to run your core components in 3 different clusters?
It's so running the core PSKE in all different regions isn't really that big of an overhead because Gardener is, so if you just run the Gardener API server and its etcd and stuff like that, it doesn't need as much resources. So maybe like, I don't know, 80 vCPUs or something like that, and 100 gigabytes of RAM or memory.
The next question is, doesn't mixing stretched and replicated clusters add complexity and operational overhead? Why did you choose both?
So we're now running like multi-cluster with stretched components across them. Of course, it adds a lot of complexity, but we wanted our database to, as I just explained, currently run in Kubernetes, and then like syncing data manually in case of a failover or replicating it with a delay or at a certain interval would just cause data loss in the event of a total failure of one region.
Okay, and was the motivation behind the use of Gardener instead of other Kubernetes solutions at plusserver?
So we looked at a couple solutions when we first started out with Gardener, I think like 3 years ago, 2.5, 3 years ago. And of course, the open source aspect of Gardener is a big plus for us, even though SAP currently still is like the biggest contributor to their own project. Yeah, but it was for us probably the easiest to get started with without buying a license beforehand or getting into sales meetings and stuff like that. And maybe also the Gardener team, so we had contact with them before actually starting our own engine, or implementing their product into our own stack. So yeah, it seemed kind of obvious at that time.
And the last question is, how do you scale a mostly stateless, in quotes, mostly stateless backend?
I don't think I quite understand the question.
I
so
think
of course,
they're referencing the fact that there is state.
Yeah, of course, there is state within the database, because of course you need to somehow keep track of what projects and clusters the customer does have. I think the point I wanted to bring across with our API server design is that everything that is not like directly interacting or interfacing with the API itself should not be handled in our API server, so we can scale it without regards to the internal state of the API pod or executable.
All right, that's all the questions we have. Let's give one more round of applause for Johann.